Okay, so number 6 is bringing back our similar triangles that we looked at the end of unit 2. So it says in the diagram, AB is the hypotenuse of right triangle ABD. So we're talking about this line right here. That's the hypotenuse. Remember, that's the longest side. So that's the hypotenuse of triangle ABD. Okay. BC is the hypotenuse of triangle BCE. Okay. So BC is the hypotenuse right here. Which of the following statements are true? Statement number 1. So statement number 1 says line CE over CB. So this distance over this distance. Okay. Would that equal, now let me clear some of this out. Let me back up here. So CE is this height. CB is this length. Would that equal BD over DA? Okay, and that just means if I were to create a fraction out of those two lengths, would they be equal to each other? Okay, now, here's what you need, here's what you need to remember. When we're dealing with similar shapes, dilations, corresponding sides would create equal equivalent fractions. So if I looked at this, if I created a fraction out of EC and EB, then I would have equal equivalent fractions because those are corresponding sides. If the sides do not correspond, then we can't guarantee that that's going to happen. Okay, so that's out. Now look at the next statement. Triangle ABD is similar to BCE. Now if we look, because this long side is shared by both long sides of my triangles, then they would be similar. Basically, one of those triangles dilated onto the other. So 2 is an option. Number 3, the slope of CB is less than the slope of BA. So here's CB, here's BA. Okay. If we look at this line, let me clear it out. So if you look at lines CB and BA, they're actually the same line. So 3 is also an option. So 2 is true and 3 is true. So you decide which answer is correct. So if you look at lines CB and BA, they're actually the same line. So 3 is also an option. So 2 is true and 3 is true. So you decide which answer is correct.